we trypsinized the cells and we had them in solution in a rather large volume in order to decrease the radiation surface.
Hello, thank you for your presentation. Congratulations for your outstanding work. Some years ago, I visited Italy, to outstanding work there. My question is, such huge power was already used all over the world, or is first time used here in Italy for biological purposes?
No, there are quite a few studies, especially on cells and also on animal models at various high-powered laser facilities around the world. But it's just that not everybody, still in the beginning, it's been a few years since high-powered lasers are around. So not everybody is looking at the same thing. Some people are looking at clonogenic survival. Some people are looking at double strand breaks.
Maybe my question is if you could be so accurate not to destroy something wrong. That is my question.
You mean the
so
cells?
accurate with curing?
With respect to tumor, if somebody tried. I see your question. If somebody tried toxicity effects in an animal model, as far as I know, I didn't see such a study. They are still, the studies are done mainly in physics labs in collaboration with biologists, but they are still very focused on the local effects as far as I saw. As I showed one study from Germany, it looked at protein side chain modifications by free radicals, and people are looking at DNA. But still, it's a bit tricky to really master the energy. If you talk about proton irradiation, you have to convey protons of a certain energy, and that's still difficult to master exactly.
Thank you.
A question about increasing the resolution from 4 Hertz to half a Hertz. Is you look also to modification in the terahertz spectrum or eigenmodes of vibrations that probably be suppressed by magnetic field and moves the energy from eigenmode to another to give you the increase in resolution and intensity?
That's a deep question. We didn't think about this. I don't know if you can. I know that protein collective modes can be observed by terahertz spectroscopy. This should be this. We advertised this when we published it the first time, and every time we did a publication of this as a quite general method for that could work in many ranges of the electromagnetic field, but you have to change the symmetry. So I don't know how you change the symmetry for terahertz spectroscopy. You have to change the symmetry of a system. Maybe it's possible. Maybe it can apply a strong magnetic field and then do a terahertz spectroscopy again and see that the signals are. This would be quite a discovery. We didn't go so far.
Thank you. It was an impressive presentation. And I have a general question. Do you think that if successful, this therapy will be possible to have access, a common access for all the people to this therapy, or it will be very, very expensive and
if you mean the flash,
the flash, laser-driven flash radiotherapy. Because I'm thinking to equipment and also to personnel who will operate this equipment.
If the flash can be quite readily made, they are they manage in synchrotrons. The problem is not the dose, it's the breaking of the doses, the switch on and off, and they manage with synchrotrons already to have quite fair doses in short amount of times below milliseconds. So yes, we are quite close to, and we are doing actually clinical studies both in Lausanne and the US. So it's not a long way ago, but still they have to show safety, and they have to analyze toxicity. Laser driven is another question. I think we are still, we have to be honest, we are still long way ago. We have to master very well the energies of the particles that we send. We have to make quite a few preclinical studies, first studies on cells. So it's a long work ahead. I don't think we are close to any real clinical application in the. Yeah, I mean, maybe it can go. It can go to clinical studies in 10 years or so. I don't know. It's maybe it's. But first, there should be studies on cells, and there should be preclinical studies. So all this has to be mastered quite well.
Thank you. Good luck.
Thank you.
Thank you very much. If we don't have any other questions, thank you once again for your presentation. Unfortunately, this opens a discussion about the financing of potential applied research. This is a very important issue, but it's not for this conference. So we have some young researchers in our institute that are very well at presenting, very good at presenting their results. They usually won the competitions, the internal competitions. So we remove them from the competitions, and we now invite them to present some invited lectures, some keynote lectures. One of them is our colleague Bogdan Trică. So Bogdan, you have the floor.
Hello. Okay, my name is Bogdan Trică, and today, for the first time in my life, I'm doing this kind of presentation. I'm not going to go particularly to the experimental part, so I'm just trying to go in a general sense towards the discussion that imagination is an important part of researchers, so I'll really focus on this as much as I can. Overall, what I want to say is that my studies were very important for me, and they gave me this opportunity to test my ideas or my general feeling about life with other people, for example, from France, where I spent some time during my master's degree. Of course, this took a few years. In fact, it was about a year and a half in Clermont-Ferrand, and then I had also an opportunity to go to Germany to do an internship. So all of these things which I would have never done were very important for me and for, let's say, my sense of imagination. And that's when I really understood that you can't really rely only on yourself and your ideas. You really have to exchange information with other people, other scientists, because you never know when you will see some new perspective that will influence you in a positive way. Now, I like pictures, and these are just some pictures from my experience over there, just so you can see that it was really a significant interaction with a lot of people. I'm not going to stay too long on this. Let's say, in some sense, this is a way in which I connected to the imaginary, where I took a picture with Bibendum from Michelin, because in Clermont-Ferrand, Michelin has its headquarters. More pictures. These are some of my professors from there when they visited us in Bucharest. And here my coordinators from Romania and from France, Professor Dobre and Professor Gervais, and also Professor Cédric Delattre, who was did a lot of work with. Now, generally speaking, what we do is we connect to reality in this kind of sense. We just take some information, and what we tend to do probably all the time is we build models of reality. So if this looks like a chair to you, this can also be a chair if you need to sit down, and instead of being a stub, it just becomes a chair. So what we do is this is really important. We just assess reality and try to use it in a sense. And I think science is somewhere just doing this, but at a more intense level and more dedicated to utility. So whenever you're working on new ideas, like you need to understand what is the sphere of knowledge, like overall what's happening, and then to try and formulate hypotheses which you check. And if everything is right and you pass peer review and there are no significant issues, then you might add to this sphere of knowledge. But there's this input here, this imagination input, where we really don't necessarily control what we think, but I think it's important to focus on this part of the creative problem, because no matter how hard you work, if you don't let a little bit of instability that comes with imagination, you won't necessarily come to new ideas. Now, this is, I'm really testing the limits of what I can do here in this situation. These are fake papers that don't exist. You can see Jean-Luc Picard, 2345. So he came back from the future. Then he became the editor-in-chief of this non-existing journal. And that's why this gives the name of my presentation. If you know these midi-chlorians from Star Wars, then you'll see that someone tried to make an SEM of a fake concept from Star Wars. So this is just one way in which we can test our imagination. This has no practical utility whatsoever, except just in this sense, whenever you're doing proper research, you try to first think with your mind and then try to apply. Now, just a few words about my thesis. I won't take too much time. So it's just we did a lot of this work on brown seaweed, which we found in the Black Sea, especially the brown seaweed, the Cystoceira barbata. And we try to see what are these, or how we can class these kind of type of biomolecules, and you know, extract them in series so that we could use as much as we can from the initial mass. Of course, there are plenty of uses for all of these type of compounds, which we try to study with respect to Cystoceira barbata. Now, one other part was this ultrafiltration of alginate, which was one aspect of the thesis. Working on this kind of ultrafiltration process, I also had to work with spirulina at one point, and spirulina has an interesting type of pigment that is blue, in fact, and this is a place where we just use ultrafiltration to increase the purity of this type of pigment. Now, coming to this imaginary part of the discussion again, had a very interesting discussion with a colleague when I was in France, because one of them, I mean, he knew my subject and he knew what I was working on, but a PhD student did not know exactly what I was working on, and that PhD student didn't necessarily know about the Smurfs. So when someone said, what are you working on? The other one said, well, he just, there are some Smurfs in Bucharest, and he didn't just take the Smurfs and make them a pigment extract, but they have these kind of flowers they grow, and Bogdan talked to the Smurfs and took some flowers. Like the PhD student for some point believed him, and I thought that was a very nice situation where you can prove that, in fact, when you're using imagination, you can still discuss about scientific methods in a way in which even science fiction works. Back to reality a little bit, but you see, I said here maybe we could do this with the Smurf flowers extract. So this was just an experiment showing that these kind of alginate films could be proven to be antioxidant, either as a soluble compound or as a film. But the general sense was that there's nothing that would make me in a different universe not to do this exactly with flowers from Smurfs. Okay. Now, another point where, let's say, I feel like I connected with this kind of imaginary situation is I do these TEMs here at the NeXT-Chem, and sometimes I like to say to tell to people, listen, if I find 10 Mickey Mouses in a sample, it's really doesn't really mean that you have nano Mickey Mouses in your sample. It's just that maybe in one situation this happened. But going further with this idea, if you would make nano Mickey Mouses, then maybe you would also have this kind of distribution of their size, because they might be smaller or bigger, but on average they could follow this kind of trend of normal distribution. Coming back to reality a little bit, this is another subject we tried here to coat seeds, and using these kind of statistical methods to assess how important or significant these factors can be. We came to a better understanding of this process, and we achieved control over this kind of coating. One situation where, let's say, we used our imagination to solve this problem was that in some sense the density of alginate film should be the same if it's at a larger scale or if it has a microscopic scale. So in that sense, a very simple situation based on this condition was that we could try and predict the thickness of this coating process on the seeds. And we did that. We got some results, which we can see here with the SEM. The seeds grew and nothing was wrong, so everything was fine. And we also understood a bit more of how important this kind of shape of the seed influences, because of course one thing is a sphere, another thing is I don't know, oblate spheroid or two sphere segments. And in this case, for example, we could prove by the pignometric method so really easily that in fact the two sphere segments is approaches this kind of situation. Now, coming back to the, let's say, the imaginary in a sense, all of these scientists, especially, let's say, Alfred Wegener, I would say, was in fact the person who proposed the theory of tectonic plates. He was ridiculed at first. So sometimes whenever you're people could be thinking that they live in reality, but in fact they're living in some kind of an imaginary situation where maybe not the best theory is generally available. So that's why I put these kind of, but this is not the case for Albert Einstein, but I'll come back to him. It's just that Charles Darwin was also maybe that's very contested at first, but then during his lifetime, he was also appreciated. Then we have John Snow, not this John Snow, this John Snow, who was in fact there when there was a cholera outbreak in London, and he was the first to claim that maybe people should just wash their hands more and be more careful with their hygiene, because maybe there are these microscopic things living around us that could get us sick. So overall, going to the editor-in-chief, like use the force Harry. Like this is the editor-in-chief of this imaginary journal. So thank you, and I just want to say that overall, this is just a way of telling, especially the young scientists, that I think they should actively focus on their imagination, no matter how their research works. They should really try to think outside the box, as we say, but also do your duties in time. Don't think too much outside the box, but pay some attention to imagination, because it could lead you down a certain path where you might completely change the perspective in some domain. So, and that was it. Thank you for this opportunity.
Thank you very much, Bogdan. It was a very nice presentation, and usually our work is on the edge of knowledge, so a very big dose of imagination is needed. So follow your advice. You and all your colleagues must follow your advice and focus on your imagination and use it. We have a question from the room, 2 questions.
Congratulations, Bogdan, and thank you for your cooperation in our presentation. Hope to be in new format. And now regarding imagination, Professor Poincaré, being mathematician, said, discussing about a former student, I remember him. In time, he has not enough imaginations to do mathematics in science, and he became a poet. Congratulations. Keep on.
Thank you very much. Beautiful presentation. I have provocations. There are lots of colors in nature, but not a lot of blue. There are some flowers that are blue, but animal furs, leaves, there's not a lot of blue. Why do you think?
Yes, it's true. I think maybe in some sense, maybe I don't know. I don't really know exactly, but I'm thinking there must be some difficulty maybe in achieving blue, like in a biological way, and perhaps it was not useful enough in some sense. But I guess I think there's some blue, right? With respect, I think butterflies have some but it's a different kind of a phenomena anyway than it's usually. Yeah, I don't know. It's true. We use this example with blue, but it's just because the Smurfs were blue. So I don't know if anyone I'll look it up.
Continuing with your ultrafiltration device and the blue color, I tried to tell you a little story about our experiment with Murphatlar wines with tangential ultrafiltration. We did the sequential ultrafiltration and took particles out, and we learned that the wine taste and color change it. And when we get up to 100 nanometer lower, wine was very diluted vodka. But sommelier took that back and tried to play with our products of particles to make the taste shift and blend it with color from other filtrations. Now the question is, have you tried that with GPT-4 or other AI machine to see if they'll get the same result? Because it's with your imagination, congratulations, you are a little bit over artificial intelligence. That's a product of real intelligence.
Yes, it's true. I don't think. I think maybe going to artificial intelligence, in some sense, I think it will be very difficult to reproduce imagination, and maybe that's the main difference. Overall, like generally, looking into the future, I think it's probably going to be very difficult. I don't think it's going to be. This is the start of proper. I think it needs a totally different mechanism in some sense, and at the moment, it's just copying really good what people have generated using their imagination, and it's just connecting the dots a bit, maybe between. But.
Thank you very much. I don't think we have any more questions, so we will have a break up to 1 p.m. After which our young colleagues will start presenting their works. Once again, thank you to our guests. Very interesting presentation, and congratulations, Bogdan.